Hello everyone, my name is Arun. Welcome to my channel. This series is a series of plotting tutorials using Matplotlib in Python. Now in this tutorial we'll be looking at polar plots. Now polar plots are very helpful if you want to have a plot that actually sweeps about an angle. Let's say for instance you have some kind of a spatial distribution wherein you want to measure the noise in all the directions. You want to do that in some kind of a polar plot. Okay, those cases the polar plots are helpful, and sometimes in mathematics, especially while working with sinusoidal curves, for instance this Rose curve or Rotonier curve. Okay, these curves have a magnitude variation about the angles, and if you want to make plots or something like this, okay, polar plots are very helpful because they help you to do all this stuff very easily. So in this video, what we're going to do is we're going to take up this simple example and we'll construct a Rose curve. Okay, we'll construct the Rose curve. This formula is fairly simple, and then we'll plot it and see what are the things that we can do. So we're going to set some parameters, generate the data, get an axis handle, plot the figure, and then we'll add some tweaks. To make sure that the plot is actually complete. All right. So let's get started. I have my program overall template written over here. We're just going to fill it. Just import a NumPy, Matplotlib, and a Matplotlib with an as a short name with MPL, and I set this default setting to be default. Okay, and now let's get started with. Okay, so first I need number of points, so let me define 2001 points. The reason why I set the number of points to be high is because the curve will be very smooth, and let the number of lobes in the curves to be 6. And let's have a scaling factor, let's say r, which actually acts as a radius, but it's kind of like a scaling factor. Okay, and now let's create the data. So first theta, which is actually the angle, let this be linearly spaced between 0 and 2.np.pi, and now let's have n number of points, so there will be 2001 points. And then let's calculate the curve. Now the curve is fairly simple. We just have to type this curve scaling factor times np.cos and then f star theta. That will do. This will generate the angle. This will generate the curve. And now first what we have to do before doing the polar plot is we need to get the axis handle of the object. Actually you can do this directly with the plt polar plot, but if you want to go and do a little bit of customization by tweaking up the axis limits and all, that's a bit how do I put it, a little bit messy, not that straightforward, so it's better we go with the axis handle. So first create an axis handle, so ax1 equals plt dot subplots. I'll talk about this in another video. Okay, as of now just follow along. This will create a simple subplot with only one figure inside, and this will have have polar properties. So if you say polar equals true, we're enabling the polar plot options over here. So instead of having the plot in Cartesian coordinates, xy coordinates, this will shift to r theta coordinates, or the polar coordinates. All right, and now what we're going to do is we'll directly give the plot. So the plot is actually simple. Just type ax1 dot plot, and then we put the angle theta and put a comma and then put the curve, and that is it. And at the bottom of the chart, we just have this plt.show. Alright, and so if I run this particular code, and there we go, we get a sinusoid, we get actually a Rose curve with 6 lobes over here. Alright, now instead of 6, if I put this to let's say 5, okay, you'll get a Rose curve with 5 lobes over here. Now instead of doing, you can actually play around and change this value of f and do whatever things you want. Okay, just for kicks I'm just going to put this to be np.pi. okay, and if I run this between 0 and 2 pi, this curve is actually incomplete because it started over here, didn't complete the full revolution. It completed one revolution, but it didn't complete my oscillation fully. So what I'm going to do, I'm just going to push this to 0 to 2 pi, thereby it completes 10 oscillations, 10 rounds. And if you look at it now, this looks more like a rosette pattern or a rose curve. This is the reason why they call as rose curves, because if you if for some particular value that which is not an integer, if you take these curves and try to plot them over and over, you will get some kind of a rosette pattern like this, and they're pretty neat too. Okay, I'm going to keep this data as this. Let's not going to change it. Let's actually go and make this plot a little more fancier by adding features. First thing we'll actually do is just add some additional tweaks because those are much simpler. So plt dot, we'll actually add a grid, and then let this to be true because it's needed, because if I just give this particular option over here, there won't be any grids by default. Okay, if I just put this grid to be empty, there won't be any grids. So if I put this to be true, now it will have grids. Alright, now it will have grids. And now let's add the legend, plt dot legend, and then let's put a title, plt dot title, and then let's put this as rows plots, and that will do. And if I run this, you will get a warning here saying that there's no labeled object form. That's okay, we'll fix that up. You have a legend, you'll have a legend that will be available, and you have a title. And now over here in this curve, in this line over here, let's actually put a curve color, and then you can put any color you want. I thought I'll use this XKCD salmon color. You can put any color you want. That's totally up to you. Let's add a label, and this label is called as rows curve. Alright, and now if I run this code, and this is what I get. I get a light faint red color, reddish color, the curve, and I get a nice rosette pattern, and the angle, and I have the legend appearing over here as well. Neat. Alright, and now what I do is this part is fine. Now I'll actually go with the main tweaks. There are 4 tweaks that you have to keep in mind that will be really helpful if you want to customize the plot. First is actually setting up the radius. So if I run this plot by default, it's actually between 0 and some higher value that we mentioned over here. We can actually control this, so we can actually set up the radius limits. So for that, the option is simple. Just type ax1 dot, and there's something called a set ylim, and here you specify the lower value and the upper value. So if I specify 0 and 6, there we go. Now this actually has it takes up the limits and sets them accordingly. So it has the lower value it keeps the lower value at 0 and the higher value at 1. Perfect. Higher value at 6. Alright, since this curve is actually confined to 5, it's not going beyond 6, but this is actually better. Okay, suppose if you want to have negative values, let's say, that's even possible. So if I put this to be something like minus 6 to 6, this will totally work out. Alright, and this particular part over here, this is actually close to minus 6, and we'll do something do something for that. Now we got the angles. Now we're able to control the radius. Let's actually control the ticks. Okay, let's specify where we need to put the ticks, and that's easy. Just type ax1 dot set y ticks, and over here you have to pass a list or a tuple or a numpy array. So I'm just going to pass linspace option, and I set this between -6 and 6, and I'm going to put like how do I put 13? I think I'll put 7. That will do. 7 values between -6 and 6, and if I run this curve over here, there we go. I get a perfect grid as per my choice, and these circles over here, they represent the various ticks. This part over here, this region over here, this corresponds to -5. So this center part over here is not 0, it's actually -6. This circle is -4, this outer circle is -2, this is 0, this is 2, 4, 6, and all. This way you have a control over the label as well as the text. Alright, now with this, let's proceed further. Next thing you might like to look at is change the tick positions of the tick positions. So instead of keeping them around approximately 22 degrees over here, sometimes you might wish to keep it vertically down or vertically up, or in some other inclined fashion, and that is possible. That's by using this radius tick position. So just type ax1 dot set. For this it's actually r label, set r label position, and here you specify the angle in degrees. So if I put this to be in 135 degrees, the labels are actually aligned along the 135 degrees line. Similarly, if I want this to be in some any angle, for instance, let's say 270 degrees, they'll just work perfectly fine. Cool? Cool? Now, what we can actually do is, let's put this to 135, that looks better. At least that's my opinion, my thought. And now what we'll do is we just put ax1. The final thing that you want to do is just set up the angle text. And that angle text is fairly simple. For this we have to look at set xtext, and then in this particular line over here we're just going to use a similar one, np.len space, and we set this between 0 and 2.0.np.pi, and let's keep how many? Let's keep an angle difference of 22.5 degrees. So we need 4, we need 3, no, 2, 4. Let's put 9. Okay, I think that should be good. Will it work? Yeah, it's okay. 45 is fine. Let me put this to 17. That should give a 22 degree angle. Okay, put this to 17. And now if you look at it, our plot is complete, and now if you look at it, we're able to have the different grids, by different label marks and different radial lines for corresponding to different angles over here. The only thing that we notice over here, this 0 and 360 degrees are actually merging, overwriting on top of each other. We have to stop that, and that is fairly easy. So here you generate all of them, and we're just going to use skip the last value by adding this feature over here. If we we're taking all the indices except the last index. Now if you put this, that 360 won't merge, won't superimpose. Cool. This way we actually completed this plot. We looked at everything that we want for this polar plot, like the curve, lines, the color of it. Of course, just because this is similar to the plot, we can have the line width and line width options, and you can put multiple plots if you want. All of that is possible. All of that is possible. And we also looked at the limits, y-text, r labels, x-text, and all. We looked at all of them. And if you want to make multiple plots, that's that's also possible. So just type this, and then for the sake of this, okay, let me just make a small correction. Let this be curve 1, this will be curve 2. So curve 1, curve 2. So let this be rose curve 1, and this will be rose curve 2. And instead of salmon, let me put this to a simple one. Azure. I think azure is kind of like bluish. Correct me if I'm wrong. Oh, it's superimposing. Oh, I think it's superimposed a lot. Oh, it's cos. I'm an idiot. I think I just had to put this to sign, and now this will work, I suppose. Please work. Yeah, perfect. And now if you look at it, this plot is actually beautiful. Alright, and this is how you actually go about with polar plots. Hope you find this example very informative. And if you guys want a little, if you're like interested and intrigued by this example, and if you want a little more of a challenging example, just go about with this page, and if you want, you can actually try to regenerate this. Try to play around with the values and get all these curves. If you want, you can actually try that if you want a little bit of a kick. And also, if you want to do a little more fancier stuff with this plots, there's actually this called as Maurer-Rose pattern, and this one is even more interesting. I didn't want to take this one because this is pretty fun to do, but for the sake of a tutorial, this is too much to work. So I thought I'll just leave it. But if you guys want, you can actually try this. This is going to be this is actually fun. And if you're able to generate some of these plots, at least one of these plots, you'll be completely thorough with polar plots. Now that's all I have for you all in this video. Thank you for watching, and I'll see you all next time in another interesting video. Till then, take care.